It's going to be at the center.
Very good. What is the center?
What is the center?
0.5 meters.
Yes, I follow. So the center is 0.5. So you draw your line to show the mass, center mass. But I'll tell you something about the mass later. They say the mass is what? 2 kilograms. So I'll write 2 kilograms. Let's continue. Is pivoted at the end P. Where am I going to draw the triangle?
At the end of the P.
At the end of the P.
Alright.
That's
So,
the beginning of the
draw the triangle.
The beginning of the P.
Yes. This is, you know, I told you guys before that can be pivoted at the end P. If load of 14 Newton is placed again, where is it placed? Load of 14 Newton is placed at the center of the rod. Again, center of the rod is not 0.5.
Yes, sir.
And we have the mass of the rod there. And they say 14 Newton is again, jam can be so crazy. Like this can make a student, to start thinking, like you waste your 5 minutes thinking on what to do. So what are we going to do here? That same center again, you draw another force and call it what? It's going to be 14 Newton
14 Newton.
at the center. Find the force that should be applied vertically upward. Please, I want everybody to watch. Look at this meter rule. Is it balanced this way? Is it going to side this way to fall?
No, sir.
No, sir. P. Q.
Somebody say
Q.
P. Ha.
The Q side.
It's going to fall towards. It might even without. Do you know that even without force, it's going to fall towards Q. Now, for you to balance it, who can tell me what to do? Because the pivot already is at the edge. What are we going to do in order to get this in balance?
We have to adjust the pivot.
Without adjusting, they say we're not going to adjust the pivot.
You need to add a vertical force upward.
You need to add for holding it upward.
Where?
Equal to Q.
Q, very. I don't know if you can see my video. You can see my video. I'm trying to show something. Let me see. Very well. Make it right. Are you seeing it?
Yes, sir.
No, sir, I can't see it. Yes, sir, we can see it.
Like, try to scroll down off the page, like the main screen. You'll see the other page. You see. Yes, sir. What's the previous answer? What was our previous answer? What did we get as our previous answer? Is it not 25 cm?
Yes, sir.
Yeah,
Is that 25
Sir.
answered your question? Yes. All right. Now, if you look at this meter rule, I don't know if you guys are seeing. Can you see my hand at the meter rule?
Yes, sir.
My hand
Yes.
is acting as if my hand is acting as the pivot. You see that already the meter rule is down, and now another force again is applied at the center, so that it's going down. It will fall off. So in order to balance this, we need to support it here at this edge. We need to put it up here so that it can balance. Are you following?
Yes, sir.
This is the only thing we can do. Like the other person said, we can move the what's it called? The pivot. Adjust the pivot inward. in order to balance it. But they said here the pivot is at the center. So in order to balance it now, they said, okay, can we now go back to the screen? I want to go back to the screen. Yes, are you there now?
Yes, sir.
Now, they said, find the force that should be applied vertically upwards at Q. At Q to maintain the rod at equilibrium horizontally. So you see that what are we going to do now? At Q, we need to draw the force up. Abi?
Yes.
And we don't know the value because they say we should find it. So can I call it maybe F? Let me call that force F. Call it anything. Are you following? Now, the next thing we are going to do. Wow. All right. The next thing we are going to do. I want you to know that we have two forces here. What and what?
14 and F2.
14 and what? And 2. That 2 and 14, are they together? Are they from the same family? Because one is kilogram and the other
No,
one
sir.
is
The other one is
Newton.
Yeah.
Can they rank?
No.
We cannot add the two together. Newton is force, 1 kilogram is mass. And you remember what I told you guys, that I can change kilogram to Newton by using this formula. Weight is equal
Is equal
to
to mg.
mass times what? Acceleration due to gravity. So can we change that kilogram to Newton so that we add the two up? W now becomes what? What is our
Yes.
the mass is what?
2
times
2
times
times
20.
what is G? It's given in the question. G is what? 10.
10.
So 2 times 10 equals 20. So what is 20 Newton? So what's the total force acting at the center now? The total force acting at the center. How do we calculate? Is it not the
34 Newton.
14?
Newton.
So the total force here now is going to
34.
20
34.
plus 14, which is what? 34 Newton. Is it clear?
Yes, sir.
Yes.
Is it clear?
Yes, sir.
Yes, sir.
All right.
Yes,
So,
sir.
we have 34 Newton. I think from here we are good to go. You can now identify the pivot is at the end of P. Remember the principle of moment. We are giving force and we are giving distance. So summation clockwise moment is equal to summation anti-clockwise moment. Then, yes, let's identify clockwise and anti-clockwise. The 34 Newton, is it clockwise or is it anti-clockwise?
It's clockwise.
It's clockwise.
Before you answer, look at the arrow. Follow the arrow to where?
To the
And follow
pivot.
the arrow to where?
The pivot.
To the pivot.
People. So follow it now and tell me now. 34 Newton.
Clockwise.
Clockwise, sir.
Clockwise.
It's clockwise. Look at it now. It's acting this way to the pivot. Look at it, this way to the pivot. Clock moves this way now. Clock moves this way. Down. Clock moving down this way. Then what about F?
Anti-clockwise.
Put below Y. Look at where the arrow is pointing. It's pointing up. Up to where? To the pivot. So this is how I will trace it to the pivot now. Is clock moving this way? Up.
No,
This is
sir.
open to the momentum. So that is why this one is anti-clockwise
Clockwise.
and this one is clockwise. All right. Remember that moment is force times distance. Yes, quickly. What is the clockwise moment now? What is the force for the clockwise? Quickly.
34. 34.
Not 34. 34 times the distance. What is the distance from where to where?
From 0.5 to 0.5.
From 0.5 to 0. To give us 0.5 minus 0, and that would be 0.5.
0.5.
Is equal to summation of anti-clockwise moment. Anti-clockwise moment now, what is the force?
F.
The force is F times the distance. The distance is from where to where? Very easy, please, guys. No time. I said, remember now, from 0 to what? To 1. 0 to where?
0 to 1. 1. 0 to
Here is
1.
1 now. So the distance is from where to where?
It's from Q to
It's from 1 to 0. There's nothing like you. You are going to solve it. It's from
0.5.
1 to. Alright. It's not 0.5. All road leads to the pivots. Remember. So it's
1.
0. From 1 to 0 is 1 minus 0, which is
1.
So F times 1. So what do we have now? F because F times 1 is equal to 34 times 0.5. Is that what? Which is going to give us 17.
Yes, sir.
Hope it is clear.
Yes, sir.
Okay. All right, thank you. Hope at this level, equilibrium and moment is easy to a certain level.
Yes, sir.
Good night.